This video is going to cover Chapter 6, Section 6, Part 1, which is trapezoids. So this section in its entirety will cover trapezoids and kites, but today we're just going to talk about trapezoids. So we continue our talk about different kinds of quadrilaterals or four-sided figures, but a trapezoid is different from the ones we've talked about before. They were all parallelograms. These are not parallelograms. So a trapezoid is a quadrilateral with exactly one pair of parallel sides. So where a rhombus and a rectangle and a square all had two pairs of parallel lines, the trapezoid only has one. The parts of the trapezoid are in this diagram. The two parallel sides are called the bases of the trapezoid, and the non-parallel sides are called the legs. Where the base meets the leg, these corners are called base angles, and they come in pairs. So these two are a pair of base angles, and these two are a pair of base angles. So again, the parallel sides are called bases, the non-parallel sides are called legs, and the two angles that share the base of the trapezoid are called the base angles. There are two theorems attached to trapezoids, and again, the number of it is not important. So yes, it's called 619 because it's the 19th theorem in chapter 6. That number is not important. However, what it says is that if a quadrilateral is an isosceles trapezoid, then each pair of base angles is congruent. So by definition, an isosceles trapezoid is a trapezoid that has congruent legs, which means that the two non-parallel side, which would be here and here on this trapezoid, if those are congruent, then it's called an isosceles trapezoid. And if that trapezoid is isosceles, then each pair of base angles is congruent. So the ones that are in line together, these two base angles would be congruent, and these two base angles would be congruent. It should make sense when you look at them that they're paired off, because these two appear to be acute down here. They're less than 90 degrees. And these two appear to be obtuse up here. So I would know A couldn't equal P because one looks obtuse and one looks acute. So A in this case would equal R and P would equal T. Meaning if this was, let's say, 70 degrees here, then I would know this is also 70 degrees. If this was 110, then I would know this is also 110. Theorem 620, again, number not important, but what it says if a quadrilateral is an isosceles trapezoid, then the diagonals are congruent. So when I connect these opposite angles, these lines formed would be congruent. Only if this is an isosceles triangle. So these two have to be marked as congruent. And isosceles trapezoid. If that's the case, then I would know that BD would be equal to AC. All right, so example 1 says ABCD is an isosceles trapezoid. What are the measures of angles A, B, and D? So in my diagram, these are now the congruent sides. Those are going to be my legs. These are my parallel lines. So the base angles in pairs would be angle C would match angle D, and angle B would match angle A. So hopefully we remember that we just said that if it's an isosceles trapezoid like this one, that the base angles are congruent. So if 100 is on C, then 100 would also be the same measure as D. So I know angle D is 100. Now because these segments are parallel, and this and the other side are also transversals, I know that these angles in here would be same side interior or consecutive interior, which means they're supplementary, which means these two are going to add up to 180. So angle B plus angle C are going to equal 180. So I'm going to take that 180 and I'm going to subtract the 100 from it, and I get 80 degrees for angle B. And then because B and A are the same, angle A is also 80 degrees. So angle B is 80 degrees and angle A is 80 degrees. So these two should add up to 180. These two should add up to 180. These two should be the same, and these two should be the same. And all four of them should add up to 360 because this is still a quadrilateral. Example 2 says, what are the values of x and y in the isosceles triangle below if DE is parallel to BD? So this actually should say BC, and then it's telling you that these two sides are parallel. Well, the first thing you should remember about an isosceles triangle, so this big triangle is the isosceles triangle, is that means the two sides are the same. So if these are my congruent sides, then we have something called base angles inside an isosceles triangle, which are the angles opposite the bottom, or opposite the congruent sides. So those two are going to be congruent, which actually has an isosceles trapezoid within your triangle. Now, because this is 32 and all three angles in my triangle have to add up to 180, if I subtract that 32 from 180, I get 148. And then because these two angles are congruent, I can divide that 148 by 2. And I get 74 degrees. So angle Y is 74 degrees, as well as angle C, or angle B, which has the Y on it, and angle C. So I already know that Y is 74 degrees. Now, because these are parallel, and again, you've got same side interior angles here, or consecutive interior angles there, I know those are supplementary. So x plus 74 is going to equal 180, and subtract the 74, and x, these cancel, equals 106 degrees. So we've got to remember the properties of isosceles triangles as well as parallel lines. Theorem 6.21 or 621 is called the trapezoid midsegment theorem. So if you remember a while back, we talked about midsegments in a triangle. Now you're going to talk about a midsegment in a trapezoid. The good news is there's actually an overlap of what they mean. In a quadrilateral, if a quadrilateral is a trapezoid, then the midsegment is the parallel to the bases, and the length of the midsegment is half the sum of the lengths of the bases. So if you remember by definition, the midsegment connects the midpoints of the sides. So because this is congruent to this, I would know N is the midpoint on that side. And because RM is congruent to MT, I would know M is the midpoint on that side, which makes this segment here the midsegment. And what this theorem tells us is that midsegment is going to be parallel to the bases, which means it would be parallel to the bottom and to the top of this trapezoid. And its length, the midsegment length here, is going to be half the sum of the bases. So if this was 5, this was 10, I would add those together, 5 plus 10, and I'd get 15. And then to find the midsegment, I'd divide it by 2. So 15 over 2 would be 7 1/2, or 7.5. And our A would be parallel to MN, which is parallel to TP. So all three of those lines would be parallel to each other, or segments, and the midsegment would be half the sum of the lengths of the bases. So sum means add them together, and then half, we're going to take that sum and we're going to divide it by 2. Okay, example 3 says MN is the midsegment of trapezoid QRSP. What is X? We just said that this is the midsegment, and the midsegment would equal 1/2 the sum of the two bases. So I can say 10 plus X minus 12 divided by 2, or 1/2 times 10 plus 8X minus 12 would equal the midsegment, which is 2X plus 11. So I would combine my like terms on the inside here, and I'd get 1/2. 10 minus 12 would be 8X, and that would be minus 2 equals 2X plus 11. And then instead of, you actually have two choices here. I can distribute that 1/2 in, and I would get 4X minus 1 equals 2X plus 11. Subtract the 2X. This is 2X minus 1. This cancels, equals 11. Add the 1. 2X, this cancels, equals 12. Divide by 2. And X equals 6. So I would say if the numbers inside the parentheses are even, I would work it out that way. I would multiply by half or divide those each by 2, making sure I do both, and then continue. If those numbers were not even, so if it said 1/2 8X minus 2 equals 2X plus 11, and maybe that one of these was odd, then the other thing that you can do is just multiply both sides by 2 to eliminate this from the left side, and I get 8X minus 2 equals, distribute the 2 in here, 4X plus 22, and then continue to solve. Subtract the 4X. 4X minus 2 equals, this is canceled, 22. Add the 2. 4X, this cancels, equals 24. And divide by 4. X is 6. So either route you take, you should get the same answer. And if you had extra time, it actually probably wouldn't be a bad idea to check it with both. But you can work either way to get that answer. And then with extra time again, you can plug these values in to make sure that they are right. So if I took 6 and plugged it in to the MN, I would get 2 times 6 plus 11, 12 plus 11, which is 23. Plug the 6 in here, 8 times 6 minus 12, that's 48 minus 12, which is 36. And then I would check by saying 10 plus 36 divided by 2 should equal 23. So I get 46 divided by 2, and 46 divided by 2 is 23, which confirms my question, my answer. Okay, so we're going to stop there today, but just a quick recap. We've got a trapezoid. A trapezoid has one pair, one and only one, so exactly one, of parallel sides. If that trapezoid has congruent legs, which the sides here are called legs, the non-parallel, the parallel are called bases. If those legs are congruent, it's called an isosceles trapezoid. And in an isosceles trapezoid, the base angles are congruent. So in this case, the base angles are where the base meets the leg. Angle 1 would be congruent to angle 2, and angle 3 would be congruent to angle 4. And then we just talked about the midsegment. The midsegment connects the midpoint of the sides of the trapezoid, and the midsegment is parallel to the bases. So all three of these are parallel. And the midsegment's length equals 1/2 base 1 plus base 2. Okay, you're going to take and submit the notes that we just completed. To the Canvas assignment labeled with today's date and the notes. And then you're going to use the remaining time to work on the homework assignment 116H3 6.6 part 1 homework. Have a good day.